Here's number 29. This is an age problem, which is one of the several basic types of word problems. With this kind of a problem, sometimes it helps a lot to do a chart. So we'll start with that. Pat is 20 years older than his son Patrick. In 2 years, the sum of their ages will be 90. How old are they now? So by reading this, I know that I have basically two pieces of information having to do with Pat and Patrick. They tell me that Pat is 20 years older than his son Patrick. I think if I'm looking for the heart of the matter, it's going to be Patrick's age. Because I start with Patrick, and to get the father's age, I'm going to add 20 to that. So, okay? So that's their age now. In 2 years, well, they'll be whatever age they are now plus 2. Think about yourself. How old will you be in 2 years? So I'm going to add 2 to that and add 2 to that. So they tell me, here's Pat's age in 2 years will be that plus that plus that. And they tell me here, oh sorry, Patrick will be this. In 2 years, the sum of their ages, so sum tells me I'm going to add, will be 90. Okay, so Patrick 90. So let's see how that's going to work out as when we do it algebraically. So here I have, this is Pat's age. Sorry, Patrick. Whoever wrote this problem giving them similar names wasn't very kind. And this is Pat. Okay, so let's combine like terms because there's nothing to distribute, so I'm going to go right to that. So there's an x and there's an x, so I'll have 2x. And here's a number, here's a number, here's a number. When you're looking at these, make sure you watch your signs. So positive 2 plus 20 plus 2 equals 24. And we're just bringing down the 90. So now I have variables on this side, numbers on that side. I'm going to get rid of this by adding the opposite. This is actually going to, since this is negative and this is positive, I'm going to find the difference. 10 minus 4 is 6. I borrowed 1, so that's 8, so that's 66. Okay, so I zeroed that out, and there's my 2x. So now to get x by itself, I have to divide out the 2, and on the other side I'll divide by 2 as well. X equals 2 into 66 is 33. So that tells me part 1 of my problem. That tells me how old Patrick is. So Patrick is 33, and his father, Pat, is 20 years older, so he will be 53. Make sure that you report both the ages. Don't just solve the problem. Make sure that you go in and you answer whatever is the requirement, because if you don't do it, you'll get marked wrong. That's the sad truth of it. Let's take a look at the last one. A car rental company charges $10 a day and another 16 cents per mile. If a car was rented for 1 day and the total charge was $23.92, how many miles was it driven? So you can do a chart, you can do a lot of things with this, but sometimes it helps to sort of think about things this way as a total. So here is the total charge for the day, which is $23.92. And we know that it charges automatically $10 a day, which is about half of that. So that's $10 for the fee charge, and then the rest of it is per mile, right? So I can look at this and think, I got that. I got the total, so I'm missing this. So this is my unknown. But I do know one thing about it. I know that I get charged 16 cents a mile. So it's the number of miles, right, that I'm looking for. But that number of miles is charged by 16 cents. So I'm going to multiply that and add that. So again, if you're looking for the heart of the problem, it's right there, because that's what we have to find. All right, so let's see how this would look algebraically. Here's my equation. There's my total. Here's my $10 a day. And here's my unknown number of miles times the rate. So again, I have a variable on this side, number on that side, so all I have to do is get rid of this. So minus 10, minus 10. Okay? So that will be 0.16 miles equals 13.92. I'm going to divide this side by 0.16, and I'm going to divide this side by 1.16. So that's how we do it. And that, thank heavens, is finally the end of this, and that means that the car went 87 miles, and that's it for now.